Hey there, we're back. Now, in 10.1, we kind of laid down the foundation for hypothesis testing, namely how to set up your hypotheses and such, write your conclusions, what errors are, these kinds of things. But you have yet to do any of the big heavy lifting. I mean, for starters, notice you haven't used Excel yet to do anything. So something mathematical's coming, right? And it's going to happen right now. Now, notice that I'm hopping here just like I did in chapter 9. I'm actually going to skip over a couple sections. I'm skipping 10.2 entirely, and I will cover a bit of I will cover all of 10.3, but I'll do it after I do 10.4. The bit that is in 10.2 that you need, and I believe is still in your homework problems and such, will show up just automatically in these sections, so don't fear. All right. So when we observe results that are unusual or unlikely under the assumption that the null hypothesis is true, we say that the result is statistically significant and we reject the null hypothesis. So let me just think about that for a second. When we did our first example way back, I showed you the dice roller online or my class data right here, and you knew something was up with Steve because Steve was way down here, right? And what did we assume to be true? We assumed that those dice were fair unless we could prove it otherwise. And we sort of did prove it otherwise, right? Hold on, I gotta find my page again. There we go. Okay, so is the result statistically significant? Well, yeah, Steve was so far away from the rest of us, right? So we reject that the dice were fair, right? Which was the null hypothesis, right? You assume the dice are fair unless you can prove it otherwise, because Steve's data was so far away from the rest of the class. Crafty Steve out there lying or doing whatever he's doing. Okay, that's the classical approach. When somebody's far away, in other words, if their z-score is really high, right? If they're like 5 standard deviations away from the rest of the group, that's a sign. Okay? All right, now the other thing you can do, sorry, just fixing my pagination here, is you can think of the p-value. What did that mean? Well, you reject that the dice were fair because the probability of Steve getting 12 out of 12 rolls to be fives by fluke, i.e., oh my gosh, I can't spell, random chance, is so very low. Matter of fact, in chapter 6, you learn how to find the probability. It involves a binomial distribution. Okay, so that's the p-value method. Now, both of these methods kind of go hand in hand. You think, oh, okay, well, I know that I'm going to reject the null hypothesis that the dice are fair because he's so far away from the rest of the group. Or I know I'm going to reject because chances of him getting what he got are so low. And of course, we assume always that Steve is unbiased. Well, here, not just Steve, but that all dice rolls are unbiased and random, right? We assume that he's not lying. No one's lying about their data. No lies about data, etc., etc., etc. Now, in real life, of course, that's kind of hard to accomplish, having everything being random and unbiased, but we're just going to assume it for our purposes, okay? Okay, so we assume that everything's fair and unbiased, and then if that's the case, then him getting what he got is so unusual that we think something's up. Something's fishy. And that leads us to the 6 steps of hypothesis testing. Now, this is the first one of many such tables you're going to run across. This is the one for proportions, right? It's a 1 proportion z test. So you have to assume that it's obtained by simple random sampling, what I was just saying. You have to assume, or you have to figure out whether n times p times 1 minus p is greater than 10. We learned this in chapter 6 and then again in chapter 8. This is to ensure that it's normal for a proportion. You have to assume that samples are independent. That's why n has to be less than 5% of capital N. If that's the case, then you get these hypotheses, which look like this. And then you have test statistic and then these different approaches and so on. And notice the last part stating the conclusion. That's there is enough evidence, blah, blah, blah. All right, so we'll be back in the next video. We're going to go through this step by step for our jury panel.